Hi everyone, so today's video is about equilibrium. So equilibrium is when the sum of forces equals zero. Oh, and so that's what's written at the top there. So we've got our, we have our sum of forces equals zero. So it could occur when the acceleration is zero, which either means the body is at rest or the body is travelling at a constant velocity. We're going to focus on when there are three forces acting on an object in the centre, holding that object in equilibrium. So when that's the case, there's three different ways we can solve these questions. One is using a triangle of forces. So we've got here all of our three forces acting on this centre point, and we've still got the same directions, so F3 heading up in that same direction, F2, that was a horrible tracing. Anyway, hopefully you can see that the forces that we're looking at here are in the same direction as the ones in the arrows. So it ends up making a triangle. And in terms of vectors, if I add them all together, top to tail, we end up back where we started, which is why the vectors sum to equal 0. Once they're written this way, we can work out some of the angles between them and use the sine rule or possibly the cosine rule to work out lengths and angle sizes, so the magnitude of the forces and the angles. Lami's theorem is another one. Now, I'm not going to go into where this comes from for now. Essentially, it is to do with writing our forces as a triangle of forces and using the sine rule. But it is just a nice, convenient way of working out the magnitude of a force and the angle without putting them into a triangle. So it is still coming from the sine rule. So P, our force in the upwards direction, over sine of P, that's the opposite force, the force between the angle, between the opposite two forces, equals Q of sine of Q. So the force over the angle between the opposite two forces equals R over sine of the opposite angle. Just like with the sine rule, you would only use two bits of this equation at any one time. The third way is to resolve forces, which is like we normally do, and we're going to go through and see how these three different examples, these three different methods can work. So to start with looking at triangle of forces, we always need to draw a force diagram to begin. So a particle is in equilibrium, so our forces are balanced and is acted upon by three forces. The first acts horizontally and has a magnitude of 5 newtons. So acting horizontally and has a magnitude of 5. The second force of magnitude 6 newtons acts at 60 degrees to the first force. So coming up at 60 degrees to the first force with a magnitude of 6 newtons. And we want to find the third force. So when it asks us to find it, that means we would need to be referring to the magnitude of the force, so the strength of it, I suppose, and also the direction. Now, just from looking at this, hopefully it makes sense to you that if we want this object here not to be moving, the third force is going to have to be coming down this direction somewhere. It's the only way this is going to happen. To create our triangle of forces, we need to draw our forces from top to tail. So if I start with the 5N force that I have, I think I drew that a bit long. I'm going to run out of space if I'm drawing diagrams quite that big. Let me just try again, draw a littler one. So I've got my 5N force here. I'm now connecting my 6N force top to tail. So I'm going to join it on, coming up in the same direction that it was before, here. Now, as we're joining this, the angle made with the horizontal was 60 degrees, which means this angle in here is 60 degrees, which means because these are angles on a straight angle, they're supplementary, that this will have to be 120 degrees, so it adds up to 90. Our final force, because we're joining them top to tail, is then going to be coming up in that direction there. So our three forces joined top to tail. That 6N is kind of in the way there, so let's just, if I can, move the label so it's outside the triangle just so we don't get confused. So that's 6N. Okay, now I'm wanting to know the magnitude and direction. So what we can be saying here is that I want to know this. I'm going to call it F, the missing force, and the angle. To start with, to find F, what we have here are two sides and an included angle, so we're using the cosine rule. So to start with, we're using the cosine rule. So the magnitude of my force, F squared, equals, using the cosine rule, I square the two sides, minus 2 times the two values, times cos of the angle inside. So this shouldn't be anything new. We've done this before. Putting that in your CAS, and I'm going to skip ahead and just say when we put it in our CAS, we will get 91, which means the magnitude of that force is going to be the square root of 91. Now we want to find the angle. So because we're looking at an angle now, we could use the cosine rule again because we've got three sides, or we could use the sine rule. So up to you. I'm going to go for the sine rule because I think it's a bit easier. So sine rule says this is the side I want, this is the angle I want, its opposite side is 6. So 6 over sine theta equals our others that we know. The other angle I know is sine of 120. 120 is the other angle I know, and its opposite side is F, which was my answer there, square root of 91. This means that sine theta is going to be equal to, if we flip it over, rearrange and solve, so we're going to rearrange my equation, and then we can put this, oops, sorry everyone, we can put this in CAS. Where have I gone? Okay, so if we're putting this in CAS, we're wanting to go inverse sine, so trig, inverse sine, generally want to be in degrees because our other angles were in degrees as well, of 6 sine of 120 over square root of 91, and we get an answer of approximately 33 degrees. So we get an answer of 33 degrees. But how do we describe this? We can describe the angle, the magnitude of 91, square root of 91, easily enough. What does this force mean in terms of the others? So this force acting downwards, we can see where this force along here correlates to this one here. Oh, gosh, I can't even draw straight at all, can I? Correlates to that one there. So if we're matching it with this one, the angle at the bottom, this angle here, is 33 degrees. So if we want to be trying to describe the angle that this makes with another force, if this is 33 degrees, that means this angle in here is 33 degrees, which means the angle that my new force is making with the 5N force is 147 degrees. So we need to describe the angle with reference to another force. So we would say, therefore, the third force has magnitude of square root of 91 and makes a clockwise angle of 147 degrees with the horizontal force. So we do need to have some kind of reference for the angle. And so that's how we can use our triangles of forces and the sine and the cosine rule to solve one of these questions. In the next one, we're now going to look at using Lami's theorem instead. So we have a particle of mass 5 kilograms hangs from a fixed point O by a light inextensible string. Remember, inextensible means that it can't change length, it can't extend, it's not stretchy. It is pulled aside by a force P newtons. Okay, so I've got a wall here. Oh, let's pretend that's straight. Fixed point O, a mass 5 kilograms is hanging down. So here is my mass. That's what's going on with its light inextensible string. Okay. It's pulled aside by a force of 100 degrees with the downwards vertical. So downwards vertical is actually our force. We have a weight force of 5g. We're making an angle of 100 degrees with that, which means it's being pulled aside by a force P, like this, with 100 degrees. And we will also have the tension in the string. We want to find the value of P. So if we're using Lami's force here, we have our 100 degrees there. The string is inclined at 60 degrees, so this is 60 degrees here. So if I'm trying to find some other angles, now if this is 60 degrees, that means this angle in here is 60 degrees, they're alternate angles. If this is 100 degrees, they're going to add up to 180 altogether. So this angle in here is going to be 80. Altogether, my forces want to add up to 360. So 60 plus 80 is 140, plus 100 is 240. That means this is going to be 120. So if we were to just draw this separately for a minute, because I've got forces going everywhere, it looks a bit confusing. I've got I've got my 5g force coming down here, P in this direction, T in that direction. I have 120 degrees here, 100 degrees here, and 140 degrees here. That should be a 4, and that should be a 0, 120. Okay, so now when we're using Lami's theorem, you could do this with triangle of forces as well, by the way. It's entirely up to you which method you choose. I'm just wanting to show them all to you. Find P. So P is what I want to know. Lami's theorem says P over sine of the angle between the two opposite forces, which will be 120, equals, the other force I know is 5g, the opposite angle is 140. So that means that P is going to be equal to 5g sine of 120 over sine of 140. And we can pop that in our CAS. So we've got 5g, so 5 times 9.5 sine of 120 over sine of 140. And we get an answer there. Oh, sorry, that's not right. G is equal to 9.8. Sorry, everyone. So we get an answer of 66.02 if we're rounding. So our answer, 66.02 newtons. Now, as always, these examples are not great ones. Generally, in the question, it will tell you how many decimal places to do your answers to. Let's continue on. So now we've got another example, and we want to do this one using the resolution of forces. So we're going to resolve horizontally and vertically this time. This is the third method you might choose. A 5 kilogram mass is supported by a string pulled aside by a horizontal force F. So similar situation to last time. We've got our wall here. It's there, it's hanging. Here's our mass, okay? We have a 5 kilogram mass, so we have the weight force of 5g. We have our tension in the string, and It's pulled aside by a horizontal force, so horizontal force here, F, so that it makes an angle of 25 degrees with the vertical. 25 degrees with the vertical. If that's 25 degrees, that means that this is going to be 25 degrees here. So if we were to resolve this T force horizontally and vertically, we've got a right angle triangle here. We've got the opposite side, so this part of the force, this component of the force will be T sine 25, and we've also got this component of the force there, which is adjacent, which would be T cos 25. So we can resolve vertically and horizontally. So if we resolve vertically, because it's held in place, that means the forces are balanced. So our force acting upwards is this resolved force here, T cos 25, and that needs to equal our force acting downwards, which is 5G. So that means that T is going to be equal to 5G divided by cos of 25. So we pop that in CAS. We've got 5 times 9.8 divided by, remember gravity is 9.8, divided by cos of 25. So we get 54.07 if we're doing 2 decimal places. Where's my mouse gone? I've lost it. Okay, here it is. So that's going to be 54.08, is that what I said? 07 newtons. To find the value, so we found T, we also want to find F. So to find F, we can now resolve horizontally. So if we're considering the horizontal forces, because they're balanced, our force acting to the left is this part of the tension force. So T sine 25 equals our force acting to the right, which is F. Because we know the value of T from before, so we're going to take our value of T that we had here and multiply that by sine of 25. So we will get an answer there of 22.85. So F is going to be equal to 22.85 newtons. Now in the exams they will never tell you a specific method to use. It is entirely up to you whether you want to use the triangle of forces method, Lami's theorem, or the resolution of forces. Sometimes it might be that some questions are more easily done in one method than another, but that choice is up to you. Let's try another one with resolution of forces. So a particle of mass 2 kilograms hangs from a fixed point O. So here we go again, hangs from a fixed point O by a light inextensible string of 2.5 meters. So this, it's not a force, that's the length of the string. Here's my object. It's pulled aside a horizontal distance of 2 meters. So pulled aside a horizontal distance of 2 meters by a force P newtons inclined at an angle of 75 degrees with the downwards vertical. So my downwards vertical is my weight force here, which is 2G. 75 degrees is my P force. It's coming at an angle of 75 degrees. We want to, and we have tension in the string. Okay, it's in equilibrium, so our forces are balanced. So we're going to be resolving horizontally and vertically again. I might just put this 2G on this side, I'm going to make myself a little bit of space. So resolving this first one is fine. I can resolve it into 2 parts. I will have the horizontal component is the opposite, so sine, P sine 75. And the vertical component here is the adjacent component, so that'll be P cos 25. Now we're also going to need to resolve this T force horizontally and vertically. Problem is that we need an angle first, so we need to work out what this angle is. Luckily, we can work out that angle. So looking here, I've got the adjacent side and the hypotenuse. So cos of theta is going to be equal to adjacent over hypotenuse. If we multiply everything by 2, we can write this as 4 over 5, which means we're actually getting one of our nice little right angle triangles. So if that's 4, that's 5, this side's going to be 3. It's one of our Pythagorean triples. Let's now resolve horizontally and vertically. So if we look horizontally, we will get our forces to the left. That's going to be this one here, which it's the adjacent side, so it will be T cos of that angle theta equals our force to the right, which will be this one here, P sine of 75. I know cos of theta equals 4 over 5, so that will be 4 over 5 T equals P sine 75. I can't solve that at the moment because I've got 2 unknowns, but that's okay. Let's now resolve vertically. So if I'm resolving vertically, I have my forces acting upwards. So heading up, we've got this part here. It's the opposite side. So I've got T sine theta equals my forces acting downwards. I have this bit of it here, P cos 75, plus I've also got the 2g weight force. From my triangle here, sine of theta equals opposite over hypotenuse. So I've got 3 over 5 T equals P cos 75 plus 2g. So we want to put it in our CAS to work out our values. We're going to have to solve simultaneously. So we set up our simultaneous equations. So we've got 4 over 5 T equals P sine 75 equals, here we've got 3 over 5 T equals P, oops, not Q, equals P cos 75 plus 2 times G, which is 9.8. And we're wanting to solve this for T and P. So solve for T and P. And we get our answers here that our tension is 50.82 newtons and the force P has magnitude 42.09 newtons. So once we solve simultaneously, therefore we will get our answers. T is 50.82 newtons and P is 42.09 newtons. So a few different ways of solving these questions. One last one that we're going to have a look at before we finish up is a question that was on an exam as a multiple choice. So we've got 2 light strings of 4 meters and 3 meters connect to a horizontal mass as shown below, and we want to work out these values. Now there's a few things to think. Again, there's different ways of doing this question. Where's my mouse gone? Over there. Okay. So if we're drawing our forces, we of course have our weight force. We don't actually know. It doesn't tell us the mass. We could call it mg maybe. We've got our tension 1 and tension 2, 2 different strings, so that's why we have 2 different tensions. we want to find the ratio of their tensions. We could use Lami's theorem, or we could use something else. It's really up to you. Or we could use triangle of forces. If we were looking at this, let's try to find some angles. We don't have any angles yet, but we've got this triangle 5, 3, 4. So we've got our nice little triangle here, 5, 3, 4. And this is a great one because it's a Pythagorean triple again. We have a right angle here. Let's say I'm going to call this angle here theta. If that angle is theta, then that means that I can have sine of theta is going to be 3 over 5, opposite over hypotenuse. Cos of theta is going to be 4 over 5. If I'm calling that angle there theta, I'm calling that angle theta there, which means because they're alternate angles, this is theta here. That would then be 90 plus theta. Although that's going to involve, if we kept dealing with that, we'd then have to use the symmetric properties of sine and cos, which might make it harder. I think an easier case in this instance is to instead turn it into our triangle of forces. So if we start with that T1 that I have here, T1's coming in this angle, and that force there is theta. If I was to then connect T2 coming up here, and then that means my third force, my weight force, is coming down here, mg. So we've got theta here. T1 and T2 make an angle of 90 degrees, so that means this is an angle of 90 degrees. T1, we've got this is an angle of theta here, which means this is an angle of 90 minus theta, which means this angle is theta, because our angles need to add up to 180 degrees. I'm going to focus on theta because that's easier than having to deal with 90 minus theta and think about symmetric properties. So focusing on theta as my angle, if I was using sine of theta, it's going to be equal to the opposite side, which is T1, divided by the hypotenuse, which is this mg. I don't know what it is, my weight. So that means that T1 equals mg sine theta. We know sine theta is 3/4, so that's going to be equal to 3/4 mg. If I'm dealing with cos of this angle, so cos of that angle theta is going to be equal to T2 over mg. So T2 equals mg cos theta, and cos theta equals 4 over 5. So I've got 4 over 5 cos theta. I've just realised I've written this other one incorrectly. Sine of theta is actually 3 over 5. Okay, so that's going to be 3 over 5. I want to find T1 divided by T2. So I've got 3 over 5 mg divided by 4 over 5. I've written a lot of things incorrectly here, sorry. That needs to be mg as well, doesn't it? Okay. Where's my pen? 4 over 5 mg. So 4 over 5 mg. mg divided by mg will cancel out. I've got 3 over 5 times 5 over 4. My 5's will cancel out, and I will end up with an answer of 3/4, which is our option B. So there were a few different methods shown to you in this about how you can work through these. Up to you which of those 3 methods you choose to use for any given question. If you have any questions about this, please make sure that you let me know. Otherwise, enjoy the rest of your day. Thanks for watching.